This is assessing normality. And we got a normal probability plot. This is a graph that plots the observed data value versus normal scores. Normal score is the expected z-score of the data value, assuming that the distribution of the random variable is normal. Now this is how we'll do it. To draw a normal probability plot, you arrange the data in ascending order. Compute f sub I, that's equal to I minus 0.375 over n plus 0.25, where I is the position in the list and n is the number of observations. And then we'll find a z-score corresponding to f sub I from the standard normal distribution table. And then we'll plot the observed values on the horizontal axis and the corresponding expected z-scores on the vertical axis. Now once we come up with our graph, our guidelines is reject normality if more than one outlier is present. Now this is from our an old edition. I kind of like it, so I kind of kept it. And reject normality if the normal quantile plot does not follow a linear pattern, more or less. Now this is an example. The dots there are your normal quantile, or normal probability plot, sorry. And these curved lines here are guidelines that Minitab puts in there, and it just to see if all the dots are within those guidelines. In this case, they are, and this follows a normal distribution. It's more or less a line. Now, if I look at this example, you see my little curved lines here. Well, definitely we have two or more outside of it. And if I look at the histogram based upon this data, you can see it's skewed. So this doesn't follow a normal probability plot. Let's take a look at how to create one. And first I'll do it by hand. This is kind of for fun, but I suppose if you don't have a calculator, then this is how you do it. Now, I'm not going to require you to do it by hand. You can use calculator to do it. There we go. It says draw a normal probability plot by hand. In class, I sometimes don't have room or time to show this, so but here at home I do, so I can put in a little video. Okay, so the first step, arrange the data in ascending order. Well, it's already in ascending order from smallest to largest, so we're fine. And then we want to compute f sub I. So let's do that. Now, now I is a position list, n is the number of observations. So these are our observations, and it says down here is plot the observed values on the horizontal axis. Horizontal axis, that's our x-axis, right? So I'm just going to put x values here, and then we're going to have. Actually, let me do this down below here. So we got 30, 32.1, 35.7, 40, 43.2, and 44.5. Okay. So I is a position in the list. So this is the first position, second, third, fourth, fifth, and 6. And n is the number of observations. We got 6, so n is equal to 6. And f sub I is equal to I minus 0.375 n plus 0.25. So this particular one here, we're going to have I is 1. So we got 1 minus 0.375 over n, which is 6, plus 0.25. This one will be 2 minus 0.375 over 6 plus 0.25. This one will be 3 minus 0.375 over 6 plus 0.25. And this one will be 4 minus 0.375 over 6 plus 0.25. And this one will be 5 minus 0.375 over 5 plus 0.25. And this one will be 6 minus 0.375 over 5 plus 0.25. Now the key to putting these in your calculator is put parentheses around top, parentheses around the bottom. So if I come here, I'll do a beginning parentheses, 1 minus 0.375, close parentheses, divided by beginning parentheses, 6 plus 0.25, closing parentheses, enter. 1 minus 0.375, 6 plus 0.25, we got 0.1. Next one. I can do a second enter to bring up the previous entry, and then I can do an up arrow and left arrow, go clear to the left or something like that. Anyway, change that to a 2, and we get 0.26. And then I'll do second enter, bring up previous entry again. What did I do? I don't know what I did, but let's try it again. Second enter, up arrow, right arrow, put a 3 there, and we get 0.42. Do a second enter, bring up previous entry. What do I must be blind. I even have my glasses on. I know what I'm doing, but I'm doing second plus. Ignore the senile person behind the curtain. I think that was the Wizard of Oz. Ignore the old person behind the curtain. He is merely my helper. 5. 0.74. Excuse me. Then second enter, 6. And we get 0.9. Okay, so that's our f sub i's. And now it says find the z-score corresponding to f sub I from the standard normal distribution table. So here's our z-scores. This actually, the z-scores, you see it says expected z-scores on a vertical axis. So this is going to be our y-axis. We're going to put these on our x-axis, but we'll put those on our y-axis. So let's go look these up. And I think I've closed it. Oh, that's great. Oh, here it is. No, it's still there. Okay, so our first one is 0.1. So I'm looking up for the one closest to 0.1. 0.1. 0.0985. Here's one. 0.1. I guess this one's closer, isn't it? 0.1. So if I go over to the left, that's negative 1.2, and up above, I have no clue. Okay, let's try it again. Clear to the left, I go negative 1.2, and up I get 0.08, so that's negative 1.28. Assuming my eyes aren't getting off. Next one is 0.26. 0.26. 0.26. This is 0.0022 off. This is close, 0.26, so that's negative 0.64. Again, I'm finding my value that's closest to these in the table, and then I'm just going to clear the left, and that gives me my first part of my number. And then I go up, and that gives me my hundredths place. 0.42. 0.42. Here's 0.4207. Is that closest? Yeah, that's closest. So that's negative 0.20. Boy, my eyes just aren't very good on this stuff. Unless this table's just wrong. I wonder if that's right. Yeah. Some of the numbers seem kind of... Oh, I'm reading it wrong. Okay, never mind. I see it. Yeah. 0.58. Okay, that's on the next page. If I made it bigger, maybe I might actually be able to see something. Let's try that. 0.58. Here's 0.5832, and here's 0.5793. The 0.5793 is closer, so we'll get 0.20, 0.74, 0.7422, 0.389, or 0.7389. This one's closer, isn't it? 0.0011 off. So that would be 0.64. And next one is 0.9. You can probably guess what it's going to be. Okay, this one's closer. So that's 1.28. Well, look at that. 0.20, 0.64, 1.28, except for the signs are different. Okay, now let's graph this. And for says to put the observed values on a horizontal axis. So it goes from 30 to 44. So let's say this is 30 to 50. Yeah. And then we have 40 here. That'd be 35, and this would be 45. Now our z-scores. Smallest one is negative 1.28. Largest one is 1.28. So 1.4. 1.4. And 2 might be too much. Yeah, I'll go with 1.4. And then down here, negative 1.4. Well, halfway here would be about 0.7, and this would be negative 0.7. So our first point is 30, negative 1.28. 30, negative 1.28, 1.28, let's say right there. Next one is 32.1, negative 0.64. 32.1. So 32.1 be right there. Negative 0.64 be right there. Next one is 40 and then 0.2, or wait a minute, 35.7 and negative 0.2. 35.7, negative 0.2. Guessing right there. This isn't going to be perfect. 40 and 0.2. Maybe right there. 43.2. 43, maybe right there. And 0.64, be right there. And 44.5 and 1.28. Maybe something like that. And we're going to see how close I really am. This is how to draw it on the calculator. So enter data in L1. So let's just do that first. So I'm going to press my stat, edit, up arrow, clear, enter, or you can just press delete over and over on numbers. Don't press delete on L1 or L2, you'll delete the list and you have to add it back in. Okay, so the numbers we have are 30, so 30 enter, 32.1 enter, 35.7 enter, 40 enter, and 43.2 enter, and 44.5 enter. And I want to exit out, so I do second mode. And okay. So this says, well, I have to go y equals. I got some junk on there from, oh, I'm lying to you. I don't have anything there. Okay, let me do a second mode, exit out of that. So second y equals. Enter. So they want us to do enter on plot 1. Now we want to select on. So my flashing cursor is on, I'll just press enter. I want a down arrow. The one we want to pick is the one that looks like a straight line. It says the last one, but it's pretty obvious. So I'm going to right arrow over to the straight line and press enter. Now this should be defaulted to L1. If it isn't, then do second and then 1 to put an L1 there. And you want X highlighted. If it's not, put your flashing cursor on it and press enter. And these marks don't matter. Now we want to do a zoom and then choose zoom stat. So press zoom and I'll up arrow to, well, I should have down arrowed, I guess. Didn't realize I had all this here. Zoom stat number 9. And that gives us our plot. Let's see how close I am. Not too bad for plotting. I'm not very good at plotting points. Well, if we look at this, we try to think of it like our mini tab, you know, curved lines there. You have to kind of envision it. Looks like they all fall within the guidelines, and it pretty more or less is a straight line. So that would, the answer there would be yes if it was asking us if that followed a normal distribution. Let's save this. Assessing normality. It's kind of tedious to create by hand. I think that's the first time in 20 years I've created one of those by hand. Usually I just use a calculator. Assessing, which is what I would recommend. The beauty of it is that you can come up with whether it's follows a normal distribution very quickly. Well, if you have to plot points and look it up in tables and do all that, that's not quickly. Okay, so let's draw the normal probability plot on these last ones and determine if it follows a looks like it follows a linear pattern and is not a whole bunch of outliers. So let's do this one. Is that the one we just did? Never mind. That was one we just did. Okay, let's look at this one. So I'm going to press my stat, go into edit, and I'll press delete over and over to get rid of those numbers. And I want 30, enter, 32.7, enter, 40, enter, 53, enter, 500, enter, and 200, enter. And I want to exit out after I get those in, so I'll do second mode. Well, we're going to second y equals, do enter on 1, plot 1. We want it to be on. It should already be on if you created that first one. So, but if it isn't, you press, your flashing cursor should be on the on, and you press enter on it. I'm a down arrow. Again, the last one is I want to choose. This is one I want. The one looks like a straight line. So you right arrow over, put your cursor on it, press enter. And you want these to be L1 and all so forth. Now I'm going to press zoom, and I want you to zoom. I don't know why that pops up in this newer calculator, but I don't even know what it is, to be honest. So I'm going to do a second mode, exit out. And now I'll press zoom, and I want to choose zoom stat, number 9. You could down arrow to it and press enter on, or just press the number 9. Now if I look at this, this is our answer to that. Does that look like it follows a normal distribution? No, it's not a straight line, is it? If I try to even do my little guidelines, more than one outlier would exist. And I deliberately made it that way. I threw 500 and 200 in there so it would pop up like that. So I won't sketch that down. You have that right there. But anyway, that's how you create a normal probability plot, and it allows you to see if it follows a normal distribution. So let me stop my recorders.